One application for probabilities is in calculating expected value. This is something that insurance companies routinely look at to determine the premiums for their policies because they need to make sure they're taking in sufficient money overall to pay out those big claims that happen every once in a while. Here is an example. A company is offering a $200,000 policy to students who become too ill to continue their education. They're only charging students $50 per year. Sounds like a pretty good deal for the students, but let's look at it from the insurance company side. Assuming that this is rare, meaning like maybe 1 out of every 5,000 students would get this ill, that's a 1 in 5,000 probability that they actually have to pay out this money. So they're paying $200,000 times 1 out of 5,000, or on average $40 for every policy. So if they're just charging you $50, that means they're actually making $10 profit on each of these policies. So if they sell $400,000 policies, they're going to make $4 million. So sure, they do pay out a few claims, but in the long run, they're going to make quite a bit of money. So expected value is actually, in the long run, what's going to happen if this event is repeated multiple times. The expected value is calculated by multiplying each possible outcome by its probability and then adding those results. So up here, what we've really looked at is not the true expected value, it's the expected payout for this company. It's $40 per policy. If we want to talk about the expected value of the policy, we would take the $50 they make times the 4,999 out of 5,000 probability. Because remember, for all those ones they're not paying out, they're making $50. Then for the 1 in 5,000 probability that they pay it out, they're going to be losing $199,950. Where did that come from? Well, they're paying out $200,000, but they got $50 from that individual. So they didn't quite lose $200,000 there. When you do this in your calculator, you come up with a positive 10. That's positive, so they're getting a $10 profit for each policy. Let's look at a couple other examples. This one's a very simple one with a spinner. So you can tell looking at this spinner that this blue area down here is half the circle, that's a 3. So that's the most likely event. Then the green up here is a quarter of the circle, that's the next most likely. And then 1 and 2 are each an eighth of the circle, the least likely. So if you multiply each outcome by its probability, you come up with 2.875. Now there is no 2.875 on here, but what that tells me is that it's most likely going to be a 3 when I spin this. That's the most likely outcome. All right, let's look at something more practical. Here are the probabilities for medical insurance claims. So if the claim is 0, the probability is 0.70. For a $20,000 claim, the probability goes down to 0.20. For a $40,000 claim, it's 0.06, and so on. So if we multiply each amount of the claim times its probability, all the way down the chart, and then add up all of those, we come up with this figure of $9,400. So what that's telling us is that the company can expect to pay $9,400 per claim in the long run. So if they want to just break even, that's where they will set their premium, is $9,400. But if they want to make a profit, they're going to have to add to that. If they want a $50 profit, they would be charging $94.50 for every policy. All right, let's take a look at one more. We have a 30-year-old man wants to purchase a $300,000 policy. What would the insurance company charge him if it wants an expected profit of $100? Okay, so in my chart here, it says at age 30, the probability of a male's death is 0.00153. So I'm going to say, I don't know what the insurance company should charge. I'm going to call it X. So X minus $300,000. So whatever they charge minus the $300,000 they have to pay out times that probability of death Okay, that's the payout, expected payout. But remember, there's going to be a lot of cases where they're not paying out. So we're going to add to that the cost of the policy times the 1 minus the 0.00153. So the complement of a death. And when you work that out, we want that to be $100. So we do a little bit of algebra here, distribute, cancel like terms, move everything to one side, and determine that X should be $559. So if that's what the company charges, they should expect to get a $100 profit for every insurance policy like that they sell. All right, I have a couple more links here to give you some ideas in insurance and accounting where you might use expected value. Hope that helps you understand what this topic is all about.